All right, we're starting our next unit. So you're going to have to print out these notes and then take the notes on as you watch the video. So in this course, we start small. We start talking about the Earth and the Moon, and then we gradually get bigger and bigger. So then we started talking about planets in the solar system. Now we're talking about stars. And this unit is all about how we measure stars. And it's going to be about how do they know how far away stars are? I mean, they are really, really far away. You can't take a meter stick and measure it. So how do they do it? How do they tell the temperature of stars? And so on. And then our next unit is going to be, once we know about what stars are, their temperatures and so on, how did they get that way? So the first thing is going to be distance to the stars. And the first way that astronomers found the distance to stars is what's called parallax. Okay, and parallax is this: because the Earth orbits the sun, at one point it's going to be here, and when I look to see a star, I'm going to look up this way. And then 6 months later, the Earth is going to be here, and to see the star, I'm going to look that way. So because the Earth is moving around the sun, I get this change in angle, and that depends on how far away the star is. And the angle is called the parallax angle. All right, and in the diagram, the distance from the Earth to the sun is considered 1 astronomical unit. So that's a particular unit we use. It's really good for measuring things inside the solar system. So the Earth is 1 astronomical unit away. Planets that are closer to the sun, like Venus, is going to be less than 1. It's going to be in here. And planets that are farther away, like Jupiter, are going to be more than 1. So this gives you an example. Jupiter is 5.2 times as far away from the sun as the Earth is. So it's going to be out here at 5.2 astronomical units. Then, in order to find the distance to a star using this angle, we are going to say the distance is going to be equal to 1 divided by the tangent of P, where the P is the parallax angle. So it's a pretty simple formula, and I'm going to show you how we're going to use it on the next page. All right, so here is our example for this. All right, we have the sun here, the Earth here. Here is star A, here is star B. Here is the angle for A, and here is the angle for B. And then which is smaller, A or B? A is here, B is here. B is a skinnier angle, so PB is the smaller angle. So as the angle decreases, I go from a bigger angle to a smaller angle, what happens to the distance? So as angle decreases, distance increases. So the farther and farther away this thing gets, the smaller the angle is going to be. Now we're going to use the equation now. And it says the angle is 15 degrees. So like this angle up here is 15 degrees. So I'm going to put 15 in here. Now this says the tangent of the angle. So I just got to find the tangent of it. So I'm going to use my calculator here. All right. And on this calculator, the tangent, I type 15 and hit the tangent button. And I get 0.268 if I round. All right. So 0.268. And then this says take 1 divided by the tangent. So there's going to be 1 divided by 0.268. Do that in my calculator. 1 divided by 0.268. And I get 3.73. And that's in AUs. So how many times farther from the sun is the star? We would say it's 3.73 AUs. Now, in real life, the parallax angles to the stars are tiny, okay? They're not going to be like 15 degrees. They're going to be 0.0001 degree. And what does that tell you about all of the stars? Well, as the angle decreases, it gets smaller, distance increases. So since the angle is tiny, the distance to the stars is huge. And that's why we're not going to use astronomical units when we get to. Okay, that's why we're not going to use astronomical units when we get to distance to the stars. We're going to have to convert them into something like light years, which is a much bigger distance, because our distances in AUs are going to be thousands and thousands of AUs away. Now, problems with this method. Historically, the stars are so far away that the parallax angles were too small to measure. Okay, so you couldn't do it. Now today, okay, remember they're, thousands and thousands of a degree, so they're tiny little things. Today, we can measure the angles, but only for nearby stars. Okay, I think the best we can do is about 300 stars, and there's billions and billions of stars out there. So this method is only good for a few stars. We have to find another way to find it for stars that are farther away.